Okay, in 7.4, we are still talking about similar triangles, and we're going to be talking about 4 theorems today that deal with triangle similarity. And we're going to find segment lengths and do proportions and all that fun stuff. So remember the 3 ways to prove triangles similar that we learned last week were angle-angle similarity, side-side-side similarity, and SAS similarity. I missed an S. So we're based on those 3 things, we can go into more detail and figure out segment lengths of similar triangles. The first thing we're going to talk about is called the triangle proportionality theorem. It says if we have a triangle and there's a line that cuts through the triangle and is parallel to the opposite side, then basically it splits these 2 triangles, this small one AEF and this big one ABC, into 2 similar triangles. So that means that their sides are going to be proportional. And the reason why that is because if these 2 sides are parallel, that means we're going to have corresponding angles that are congruent. So this angle will be congruent to this angle. And in both triangles, in this little one and this big one, they both share this angle. So those triangles are similar by angle-angle similarity. So what that means is, let's say this side was 3, and this part was 6, and this part was 4. How long do you think this part is going to be? Well, it's going to be proportional. It's going to be 8. If you did 3 over 6 and 4 over 8, they're both going to have the same ratio, same proportion. So that's what we're doing today, is we're going to set up proportions. So number 1, we have parallel lines. That means that the triangles are going to be similar. So we want to figure out what US is, so I'm going to put an X there. We can set up a proportion. So I look at the same side of the triangles, and that helps me. So I say 14 over X equals 10 over 4. So I went from the top down, or from the left to the right, left to the right. Another way you can set up your proportion is to look at the triangle. So 14 over 10 equals X over 4. Either way, if you cross multiply, you're going to get the same thing. You're going to get 10x equals whatever 14 times 4 is. I think it's 64? 56, just kidding. And then when you divide by 10, you're going to get x equals 5.6. So US is 5.6. Again, the most important thing is that you see the parallel lines. So we see parallel lines, check. We know we can do a proportion. So I look at the same side first. So I'm going to say 3 over x equals 2 over 5. There are lots of ways you can write this proportion. Cross multiply, you get 2x equals 15. And divide, and you get x equals 7.5. Now for the reflection, I want you to write 2 different ways that you can set up a proportion for number 2. And to check your work, cross multiply and see if you get x equals 7.5. So I want you to take a second and do that right now, please. I will check this tomorrow in class. Okay, second thing we're going to learn is converse of triangle proportionality theorem, and we just remembered this word was on our final. Converse means we flip what we were just talking about. So remember, they had to tell us that the lines were parallel, and then we knew that the sides were going to be proportional. This time it's flipped. If the sides are proportional, then that means that the 2 lines will be parallel. So for example, if you know this one was 3, and this part was 6, and this part was 4, and this part was 8, if you set up a proportion, sweet, and you cross multiply, we get 24 equals 24. Perfect. Now we know that EF is going to be parallel to BC. So in 3 and 4, they want us to verify or show that these sides are parallel. So what we're going to do is write a proportionality statement. So 10 over 15 equals 8 over 12. That's one way you could do it. Another way you could write it is 10 over 8 equals 15 over 12. There's a couple more ways you can write it. Now from here, you can do one of 3 things. You can cross multiply and say, well, 120 equals 120. Another thing you could do is to reduce. So if I reduce 10 over 15 and divide both by 5, I'd get 2 over 3. And if I took 8 over 12 and reduced it, I would get 2 over 3. The third thing you could do is just plug it into your calculator and you'll get a decimal. So if I get 0.66 repeating equals 0.66 repeating, you can do either one of these three things. If the numbers are the same in any of them, then we know that the lines are going to be parallel. All right, so same thing for number 4. Number 4, it says AC, this whole side is 36 centimeters, and BC, this whole side is 27 centimeters. And they want us to verify that these two sides are parallel. So to do that, you could say 20 over 36 equals 15 over 27. Or you could say, well, if this side, whole side's 36 and this side's 20, that means the leftover has to be 16. And since this side's 27 and this part's 15, the leftover has to be 12. And then you could ignore these numbers. And now it looks like this problem we just had. So you could say 16 over 20 equals 15. I'm sorry, this is 12, not 15, equals 12 over 15. And then cross multiply. I think cross multiplying is easy. So 20 times 12 is 240. And 15 times 16 is going to be 240. So that means that these lines are going to be parallel. Check. So that's the second thing that we're going to do. That's the converse. The third thing we're going to do is called the transversal proportionality corollary, which is kind of the same thing as a theorem. Oops. Okay, so what this one says is when we have 2 or more, 3 or more, it says parallel lines. So here's parallel lines. These are all parallel to each other. So I can put the arrows. And I have 2 transversals. Now that means that we have a line that's the line that's intersecting the parallel line. So there's a transversal. Here's another transversal. Now when we have parallel lines and they're being cut by 2 transversals or more, what's going to happen is these sides are going to be proportional to these sides. So if this one was 3 and this one was 6 and this one was 4 and we wanted to figure out how long this side was, well, we can set up a proportion. 3 over 6 equals 4 over x. Cross multiply and you'll get 8. All right, so that's basically what all of this says. So in number 5, we want to know 2 things. We want to know what LM is and we want to know what MN is. So since we need to know 2 things, we'd have to set up 2 proportions. So the first one I'm going to solve for is x. Now I know x is across from the 2.6, and we already know one is 4.5 and one is 4.9. So what I'm going to do is I like to look from the same side. So I'm going to put 4.5 over 2.6. So I went left to right, is 4.9 over x. That's one way you can do it, and then you're going to cross multiply. So 4.5x equals 12.74, and then divide, and you'll get about 2.83 inches. So that's for x. For y, what do you think the ratio would be? Well, y is across from the 4.1, and I already know the 4.5 and the 4.9 are together, so you could say 4.5 over 4.1, if, again, I'm reading left to right, is like 4.9 over y. There's lots of ways you can set this up, and then again you cross multiply and solve. So I want you to tell me what y equals. I want you to do the same thing for number 6, please. I'm going to check your work in class to make sure you did it. And then the last one is the triangle angle bisector theorem. This one says if we have an angle bisector, so that means we have a triangle, and we have an angle bisector, so that means it's going to cut these 2 angles into 2 congruent pieces. What's going to happen is this side triangle is going to be similar to this triangle. And so we can set a proportion. So for example, if this side was 3 and this side was 6 and this side is 4, what would this side be? So you could say 3 over 6 is like 4 over x. Cross multiply and you'll get 8. So the proportions are going to be a little bit harder for 7 and 8. So for this one, you could say x minus 2 over 32 equals x plus 5 over 40. So I went to this side and then I went to this side on the bottom. That's one way you could do it. And then you're going to have to cross multiply. So 40 times x minus 2 equals 32 times x plus 5. And then you're going to have to distribute. So you're going to get 40x minus 80 equals 32x plus, I'm going to guess 160. Boom, plus 160. Okay, then you want to get your variables on one side and everything else on the other side. And so I'm going to add 80 and add 80. And we're going to get 8x equals 240. Divide, and I think you get x equals, wait, what did I do wrong here? Oh, that's 8x. What's 160 plus, oops, I did this wrong in the morning. Divided by 8 and get 30. Whoops, I did it wrong earlier. And then you have to go back and plug it in. So when you plug it in here, you're going to get 28. And when you plug it in here, 30 plus 5 is going to be 35. And to check your work, you can go back and do the ratio. So 28 over 32 is that the same thing as 35 over 40. Cross multiply, and you'll see that they are. So the same thing for number 8. You could say 8 over 4.5 equals y minus 2 over half of a y, and then cross multiply. So y divided by 2 times 8 equals y minus 2 times 4.5. I want to see if you can do the algebra and tell me what y equals. And then for reflection number 2, this is the thing I'm going to be really looking for. There were 4 things we learned today. 4 things. I want you to draw a picture for each thing that we learned. Draw a picture.